This video is actually the continuation of the previous video as electric power and its types. In that video, we derived this expression P is equal to IV. Until here, we don't know how to achieve the maximum power in a circuit, because achieving the maximum power in a circuit have many applications. One of them is the loudspeaker. So why we don't achieve the maximum power in a circuit? Because here we have this simple circuit. It consists of the battery, and the battery have their own internal resistance. So some of the voltage will be dropped here in the internal resistance, due to which we don't achieve the what we can say the maximum power in a circuit. Because here this is the 10 volt, and if I meter the voltage, the potential meter here, due to this voltmeter we detect that this is 8 volt, and here this is actually the 10 volt. Where is this 2 volt dissipated? So that 2 volt is dissipated here in the due to this internal resistance of the battery. So how to achieve the maximum power? I think you may think that in order to achieve the maximum power, we will have to reduce this internal resistance inside the battery. So let's take that scenario. If I decrease the internal resistance, then according to the Ohm law, V is equal to I R. And from here we know that I is equal to V by R. So from here we know that if we reduce this internal resistance, due to which the current will be increased. So if we reduce the internal resistance, due to which the current will be increased, so this current will be more in this case. And what will happen to here this power? If the current will be more, and due to which this power will be maximum, this power will be also maximum due to this current. So we will achieve the maximum power. Some of you may I think that if we reduce this internal resistance, due to which this current will be increased, and due to which this power will be increased. But this is until here there is no problem. But this current is increased, but what happened to this voltage? In this scenario, if we reduce this resistance according to this formula, if we reduce this resistance, this voltage will also reduce, because they have direct relation. So in this case, in this scenario, the voltage also reduced. So here in this formula, this current is increased, but similarly the voltage also reduced. So we do not achieve the maximum power in this case. So let's try the other scenario here to achieve the maximum power. Some of you may think that we will have to increase this internal resistance. Okay, let's take that scenario. If we increase the internal resistance according to this formula, the voltage will be increased. Okay, and here the voltage, if here the voltage increase, due to which this power will be increased. Okay, but here again focus on what will happen to this current. So if I increase this internal resistance according to this formula, the current will be reduced. Here is the inverse relation. So in this case, in this scenario, the current I has reduced, But at the same, so here the same problem again appear. Here the voltage increased. In this case, here the voltage has increased, but similarly the current reduced. In this case, we also do not achieve the maximum power. So these both cases are failed to achieve the maximum power. So for that, we will have to modify this equation in order to achieve the maximum power. In order to achieve the maximum power, now we will take some mathematical operation. According to the Ohm law, V is equal to IR. So in this case, electromotive force is equal to I into R. And here in this circuit, R is actually the combination of this small internal resistance plus this capital R, which is upper by this bulb. So from here, the current I become the electromotive force divided by small r plus capital R, and this is the equation of 1. Okay, this is the equation 1. And we also know from the previous video that the power, the equation of the power is also P is equal to I square R. So this is, let's say, equation 2. So in this case, put equation 1 in this equation 2. So here this equation 2 become, if we equation 2 become, if we put the value of the current from here, this become the value of the current is electromotive force divided by R plus R. So here is the value of the current, and it have the square into R. Now this is the expression for the power here. Let's simplify this. Here we have this also electromotive force square divided by small r plus capital R whole square, okay, and into multiplication of this R. This is now the equation, and let's call this as equation 3. So here P is equal to, from the equation 3, P is equal to electromotive force whole square divided by R plus R whole square, and here we have R. Now this is the equation 3, and here we have A plus B whole square formula. So let's explore that. A plus B whole square is equal to A square plus B square plus 2AB. So add minus 4AB on both sides of this equation, on both sides. So that become A plus B whole square minus 4AB is equal to A square plus B square plus 2AB minus 4AB. So for on further simplification, it become here this become A plus B whole square minus 4AB is equal to this A square plus B square. Now plus 2AB and minus 4AB is equal to minus 2AB, and A square plus B square minus 2AB become A plus B, A minus B whole square. So this become A plus B whole square minus 4AB is equal to A minus B whole square. So here we need this expression, because this expression we have to replace this expression. So a plus b whole square become a plus b whole square is equal to, sorry, this is actually the square is equal to this a minus b whole square, and this become plus 4ab. Okay, now put this here in this case we have a is equal to small r and b is equal to capital R. So by replacing this here, the above equation become the above equation implies that here r plus this r whole square is equal to r minus this capital R whole square minus 4 into r into that capital R. So we have to put the value of r plus r whole square from here. So this equation become P is equal to this electromotive force whole square into r divided by this, and instead of this we will put this, so it become r minus this capital R whole square and minus 4r into this capital R. Okay, so this r into this capital R. Now in this case our desire is to find the maximum power. So from this relation we know that if we increase this power, if we have to increase this power, we will have to reduce this what we can say, this denominator. We will have to reduce this denominator. If we reduce this denominator, this thing here, this power will be increased. So how to reduce this denominator? So for that, sorry, here this is actually plus 4, sorry, this is actually the plus 4 and this will be the plus 4. So please correct this, this is plus 4. So now our desire is to achieve the maximum power. So in order to increase this, we will have to reduce this denominator. So how to reduce this denominator? We will have to reduce one of the expression here. So if we put r is equal to this capital R, then what will happen here? If we put this r is equal to that capital R, in this case this equation become P is equal to this electromotive force whole square into R and divided by, if we put r is equal to capital R, then this expression will be 0 and plus 4 r, this is both are same, so here I am going to write that r square. So in this case we reduce the denominator by eliminating this term. So due to which this power will be increased. So we now call this power as power maximum, because this will be maximum if we reduce this inverse term here. So here the denominator term. So in this case we reduce this denominator by eliminating this term here, r minus r, by putting r is equal to r. Therefore we can say that this power will be increased, and therefore I write P maximum is equal to electromotive force whole square into r divided by 4 r square, and this become this. So P maximum, now become electromotive force whole square into R divided by 4 into R whole square. This one R and this second R will be cancelled, and the final equation for the maximum power output will be P max is equal to electromotive force whole square divided by 4 into R, and this is the expression for the maximum power output. So this is the expression for the maximum power output. So in order to achieve the maximum power in a circuit, we will have to equal this small r, which is upper by the battery, and this capital R, which is in this case upper by the resistor. So if we put these values equal, then maximum power will be delivered, or the maximum power will be delivered to the circuit.